Man, I just realized I didn't have my microphone on. Hopefully everyone heard everything. This is a review for test of chapter 8. Good to go. I'm here. I'm right here. I'm going. All right. So it says there's a support at one end. It says there's a support at the center of the mass of the diving board, so that's right here. And then there's a force of the diver. This is the force from gravity of the diver. Now, right here at the center of mass, this diving board has mass, right? That means that it has an FG for the diving board as well, right? So this is going to be the FG for the board. Okay? Now, FG is equal to what? That's right, mg. So that's going to be the mass of the diving board, which is 14 kilograms, times gravity, which is 9.8. Okay? 14 times 9.8, so I don't have to keep putting that in my putting it in all my calculations. 14 times 9.8 equals 137.2. So we got 137.2 newtons right here. Fg of the diver. Fg is equal to what? mg. Mass of the diver is 85 kilograms times 9.8. 85 times 9.8 is 833. Okay? Now it says that the total board is how long? So that means from here to here is not 3.5, it's half of 3.5, right? Half of 3.5 is good, 1.75. And that means all the way to the other side, if I was at the center, this is also what? 1.75, making a total length of 3.5. Okay, so I've filled in all these lengths. That'll help me out later. Okay, the unknown. It said, what are the forces of the two supports? So it's asking for what is FA? What is the force at A? And what is the force at B? Okay. Our equations. So what we learned is that if this is in equilibrium, there are two equations that have to equal 0. That's that the sum of the forces, or the net force, is equal to 0. And that the sum of the torques is also equal to 0. Okay? So I'm going to solve by first filling out these equations and then going back and solving them. So my sum of the forces, I have FA going up, so it's positive. I have FB going up, so it's positive. I have FG for the board, and it's going down, so is it positive? No, it's negative. And then I got F of G of the diver, which is also going down, so it's also negative. So that's the sum of the forces side. Don't forget, it is an equation. There's an equal sign and a 0. I've seen a lot of people messing up by just writing one side of the equation, and then they can't figure out how to solve it. They'll just add and subtract things and never come to an answer. Okay? So make sure that you're writing it out as an equation. Okay? Well, if I look at this, I know FG board and I know FG diver, but I have two unknowns. I don't know FA or FB. So can I solve this equation by itself? No. So I need to go to my second equation, which is the sum of the torques. Now I can add up the torques at any point along this diving board. I could add it up at A, I could add it up at B, I could add it up over here, I could add it up in the middle. But if you want to make these problems go as fast as you can, you'll want to add it up at one of your unknown places. So in this case, that would be either A or B. Which one would y'all like to do? Okay, so we're going to add up our torques at A. Now remember that a torque is just a force times a distance. Okay? I'm not giving you any of the forces at an angle for this test. I'm only giving you perpendicular ones. So a torque is just a force times the distance. You're not going to have to use sine theta. Okay? So at A, FB makes a torque. So I write FB because I don't know what FB is. How far away from A is B? It's 1.75 away. And then I have to think. So I drew this going up, right? If I have this as my point of rotation, B is going to go this way. Is this clockwise or counterclockwise? And counterclockwise is positive. Okay? Well, the next force I have is FG board. Well, I know what FG board is. It's 137.2. Okay? And how far away is FG board? It's 1.75 away. Okay? And it's going down. So remember, this is my point of rotation. So if you're going to do this like your pencil, hold your pencil at A and push in the direction that the force is pushing. So that's pushing it down. It's going to rotate this way. Is that clockwise or counterclockwise? Clockwise. And clockwise is negative. Okay? The last one that we have is FG diver. Well, we know what the force for FG diver is. It's 833. And how far away is FG diver from A? It's 3.5 away. So I do the same thing. I'm holding at A. Is this going to make it go clockwise or counterclockwise? Clockwise. And clockwise is negative. Okay? Now this equals 0. Okay? So what I'm going to do is I'm going to simplify, and then I'm going to get FB by itself. So first thing I'm going to do is simplify. So I'm going to do negative 137.2 times 1.75 minus 833 times 3.5. So now I have FB times 1.75 minus 3155.6 equals 0. Okay, I want to get FB by itself. That means I got to move this number to the other side. It's a negative, so to get it to the other side, I have to add. Good. So I'm going to add 3155.6 to both sides. Okay, now I've got FB times 1.75 is equal to 3155.6. Okay, what's the 1.75 doing to the FB? It's multiplying, and the opposite is 2. So I divide both sides by 1.75. So come to my calculator, and I'm going to divide by 1.75. Now I got a negative because I didn't change this to a positive right here. Okay? So this should be positive. It's positive 1,803.2. So FB equals 1,803.2. Okay? How many sig figs did I have in my problem? So I come back up and it says there's 2 here, 2 here, 2 here. How many sig figs should I have? 2. So FB is actually equal to 1,800 newtons. What way did I draw it? Going up. Okay, so that's FB. That's one of my answers. Okay, so now I have FB. I can plug into this equation now and solve for FA. Okay, so FA is still unknown. Plus FB is 1803.2. Minus FG board was 137.2. Minus FG diver, which was 833, equals 0. Okay? We need to simplify, and then we're going to move it to the other side, and we'll have our answer. So I got 1803.2. That's the negative of the answer I have up here, 1803.2, minus 137.2, minus 833, and I get 833. So I have FA plus 833 equals 0. Okay, how do I get the 833 to the other side? Subtract 833 from both sides. So minus 833, minus 833. And I get that FA is equal to negative 833. Thank you. Okay, what does the negative mean? If I come up here, I'm talking about a force is negative, right? Well, I drew it up, but I got a negative, so that means it's actually going where? Down. So again, positive and negative talk about direction. If you get a positive number for your answer, it means that you drew it correctly. If you get a negative number for your answer, it means that you drew it backwards, incorrectly, right? So FA, we need to round to 2 sig figs. So it's going to be FA is equal to what? 830 unit newtons, direction, down. Okay. This is probably the most complex problem that you're going to have on your test. It's not that bad, though. I think that all y'all can probably do it without too much trouble. I would strongly recommend that you practice it, though. Okay? So you only have a couple problems like this. I'm telling you right now, the one that's on your test is going to look very similar to this. Know how to do this type of problem. Any questions on this one? Anything I need to clarify? Yes? So if it's positive and I drew it up, it's up. If it's positive and I drew it down, it's down. So the plus or minus coming out of these equations tells you whether you drew it correctly or not. Because we didn't know if it was going up or down. We just drew arrows where we knew there would be a force, right? Okay? Good question. Anything else? Okay, so whenever I'm doing the torque equation, the distance that I'm using is from wherever I'm going to call my rotation point. So we said that we were going to do our torques about rotation point A. So when I did my FB, it was times the distance from A to B. When I did FG board, it was the distance from A to FG board. When I did the diver, it was the distance from A to FG diver. Okay. Now, this brings up another point. If I had done it from B, would I have gotten the same answers? I would have. It doesn't matter which point you choose to do some of your torques. The whole equation says that the sum of the torques is equal to 0. So any point that you choose, when you do the whole thing, you'll get the exact same answer. So it doesn't matter. Some points are easier. So that's why I said, if you know that you're missing one of them, do it at that point. So I'm missing A and I'm missing B. The easiest ways to pick would be either point A or point B. If I had picked over here, I would have gotten the same answers. But whenever I went to substitute my equations, I'd have an A and a B in this one, and I'd have an A and a B in the other one. And I'd have to do simultaneous equation solving, which is more complex math. So to do the easiest math, where should you pick them? At one of your unknowns. Okay? Yes? This thing right here? Okay, so I took 1803.2, subtracted 137.2, subtracted 833, and that gave me positive 833. So I just combined all my like terms right here. I know, it looked confusing. It just happened because it was on the calculator. Yes, ma'am? Yeah, the way that we figure out whether it's going to go clockwise or counterclockwise, let me draw something real quick and see if I can do this. A little beam here. Okay, this is a beam, right? So if I were to push, if I was holding this place constant, right, and I push upward on this beam, Okay, I push up right there. Which way is it going to rotate? It's going to rotate up and around like this, right? Okay, this is counterclockwise. Okay, and it's because this part is the one that's being held, and this part is where I'm pushing. You can do this with your pencil. You hold it in your hand, and you push on the side of where the force is, and you hold wherever you're holding. You'll get the answers correctly that way. Remember, counterclockwise is positive, clockwise is negative. Good. All right, we are on to the next problem. In the spin cycle of a clothes washer, the drum turns at 635 revolutions per minute. If the lid of the washer is opened, the motor is turned off. If the drum requires 8 seconds to slow to a stop, what is the angular acceleration of the drum? Okay. Let me go ahead and switch to a better pen. Okay, so let's look at the givens. This 635 revolutions per minute. What is that telling us? RPMs. Which of my variables is that? Is it theta, omega, or alpha? It's omega. So omega that they've given us initially is 635 revs per minute. Okay? What else was given? 8 seconds and slows to a stop. So what's the 8 seconds? Delta T is 8.0 seconds. Okay? And the other thing says that it slows to a stop. So what will the omega be if it stops? 0. Okay? F. For final. Okay, unknown. Angular acceleration. So what variable is for angular acceleration? Oh, that's right, alpha. Okay. All right, so looking up here, I see I have a problem. Do y'all see my problem? What do I have right here? And what do I have here? So what do I need to do? Okay, so I need to convert. So I'm going to go ahead and convert from rev per minute to revs in a second. Okay, so get rid of minutes. There's 1 minute, there's 60 seconds. 635 over 60. Ooh, 10.583 repeating. Okay? Equation. What's my equation for alpha? So I have A equals R alpha, but I don't have A in this equation. So what's the other equation for alpha? The unit would be theta divided by delta T squared. But that's not an equation. That's just telling me my unit. I heard it somewhere in the back. Say it again. Delta omega over delta T. Remember, delta means omega final minus omega initial divided by delta T. Okay? So I go to solve. Alpha is equal to my omega final, which is 0, minus my omega initial, which is 10.583 repeating, divided by my delta T, which was how long? All right, so now I just go to my calculator. So 0 minus the answer that they gave me was that, divided by 8 is that. So alpha is negative 1.322. How many sig figs? 3 there, 2 there. So how many do I round it to? So that should be negative 1.3. I had revs, so I'm going to write rev. And on the bottom, I should have seconds squared. Really straightforward. Just plug it into the formula, right? Okay. What you have to remember on these is make sure that your time matches up. Okay. If they give you something that requires radians, make sure that matches up. In this case, I wasn't using any of the A equals R alpha or anything like V equals omega times R. Wasn't using any of those, so it didn't have to be in radians. Okay, so I kept it in revs because I just didn't want to change it out. Okay, questions? All right. We'll go on to the next one then. Okay. So, this is from the worksheet. It says the Earth rotates one time every 24 hours. How many RPMs is this? Okay, so what they're giving us right now is they're giving us omega. That's one rotation or one revolution every 24 hours. That's my given, right? Okay. The unknown is they want us to do omega in RPM. That means that they want it in revolutions per minute. Okay? All right, so I'm going to go ahead and just do it right here. There's no real equation for this. It's just unit conversion, right? Okay? So at the very end, I want revs on top, and I want minutes on bottom, right? Okay? Okay, so I got revs, and I got hours. I don't want hours, I want minutes. And in 1 hour, there are 60 minutes. So I'm ready to go to the calculator now. I'm going to use the magic fraction button because I haven't used that in a while. 1 times 1 is 1 on top. On bottom 4, I had 24 times 60. Boom. There's my answer. 6.94 repeating times 10 to the negative fourth. So 6.94, or I guess it's 2 sig figs, so 6.9 times 10 to the negative fourth revs per minute. I can circle that, that's my answer, or box that, that's my answer. That matches up with the answer they gave me, so that's good, right? I told you that their answers might have the wrong sig figs, so again, like normal, you need to make sure that you have the correct sig fig. Okay, part 2 of this problem. It says, what is the velocity of a person standing on the surface of the Earth that's 6,378,000 meters from the center? So the new given is that the R is equal to 6,378,000 meters. They just gave us the radius, right? What's the unknown? Velocity, V. There's an equation that relates velocity and angular velocity. What is it? Yeah, V equals R omega. Okay? Now, to use this equation, what does my omega have to be in? What unit does it have to have? That's right, it has to have radians per second. Okay, to use this, it has to be in radians per second. So that means I need to do a little bit more unit conversion, right? Okay? So I had omega was 1 rev every 24 hours. We already said to convert from hours into minutes, we would do this. There was 1 hour and 60 minutes. Okay? At the end, I need it in meters and seconds. Or I'm sorry, I need this in radians over seconds. Because I have to have my omega in rad per second to use this equation. Okay? So I'm done with hours. I've still got minutes, though. I need to get to So minutes needs to go on the, and then I can write seconds on the bottom. In 1 minute, there are 60 seconds. Okay, I've got rev on top. I don't want rev, so I put rev on bottom. And I put what on top? 2 pi rads. That's right. Okay, I'm going to go back to my calculator. I'm going to use my magic fraction because I want to. On top, I got 1 times 1 times 1 times 2 pi. So on top, I just have what? 2 pi. On bottom, I got 24 times 60 times 60. That gives me 7.27 times 10 to the negative fifth. And that's going to be rad over seconds. Okay. So now that my omega is in rad per second, I can plug it into my equation. So it's just V equals the R, which was 7.8000 times my 7.27 times 10 to the negative fifth, and I'll get my answer. So all I got to do on my calculator is 6378000 times answer. Notice I'm not using the rounded answer I wrote down. I'm using the number from my calculator, right? Hit enter. We hit 463.8. How many sig figs did we have? 2. So that means we get 460 meters per second. That line up with the answer that they told us we were supposed to get? Yeah, just to different sig figs, right? All right, questions on this one? So I told you on this worksheet, they gave you answers that weren't necessarily rounded correctly. So we have to round correctly because y'all know I make y'all round correctly. That's part of the answer in my class. Yes, sir. So the way you put the scientific notation into the calculator, you hit 7.27. This double E means times 10 raised to the power. And in this case, the power was -5, so I put it in like that. Take a pass. Yep, the E means times 10 raised to the power, and whatever comes after the E is the power. Okay? You ready for another one? Yeah. All right. Calculate the linear speed of the tip of each hand of the following clock. Okay. So linear speed is V. What equation do I have for V? Good. V equals R omega. Okay, so each one of these hands on the clock we know has a different angular speed. What unit do I have to have their angular speed in? Rad per second. Good. So all of them have to be in rad per second. Okay? And they gave us the radius for each one. So this is the radius for the hour hand. This is the radius for the minute hand. This is the radius for the second hand. Okay, so we have 3 things that we're going to solve. So let's start with the second hand. Okay? So this is solving for the second hand. So how far is it all the way around the circle? What's my angle all the way around a circle? 360 degrees, but I need it in radians. So how many radians is it all the way around the circle? That's right. There's 2 pi radians around the circle. Okay? How many seconds does it take to go around the circle? 60 seconds. Okay? I guess I left off an equation. Omega is just theta divided by delta t, right? Okay, so I know the theta to go around the clock is 2 pi. I know the delta t to go around the clock is 60 seconds, right? Okay? So omega for the second hand is equal to 2 pi over 60. That's the theta divided by the time, right? Okay, so now I can plug it into this equation. V is equal to the R for the second hand is 0.12 times the omega, which is 2 pi over 60. So I'll go for my calculator, 0.12 times 2, oops, don't need to hit the control button, pi divided by 60, I get 0.0126. Well, I only have 2 sig figs, right? So that's going to actually be what? 0.013. Don't forget to round correctly. 0.013 meters per second for velocity. Okay? We're going to do another one. Let's do the minute hand now. So we're talking about the minute hand. So, again, as the minute hand goes all the way around the clock, how much theta is that? 2 pi. How long does it take the minute hand to go all the way around? 60 minutes. But remember, I need radians per second, so what do I need to do to my minutes? Convert it to seconds. So there are 60 seconds for every 1 minute. That means that there are 3,600 seconds in an hour. Okay? We're going to do the exact same thing we did last time. Omega for the minute hand is equal to 2 pi over 3,600. Right? And then we're going to plug it into the V equals R omega. So V is equal to, well, the R of the minute hand is 0.15. And the omega was 2 pi over 3,600. Go to my calculator. 0.15 times 2 pi over 3,600. And I get 2.61799 times 10 to the negative fourth. Let me check up here. It does say 0.15. Okay. And I put 1.15? Okay. I just had to make sure because it's not matching up with the answer here. But we got 2.6 times 10 to the negative fourth. Meters per second. The last one is going to be the hour hand. So again, for the hour hand, how far does the hour hand go around the circle? 2 pi. Okay? And how much time does it take it to go around the circle? 12 hours. But we already know we can't use hours. What do we need to use? So get rid of hours and go to seconds. Let's skip a step. We already know how many seconds are in an hour. We did it on the last problem, right? There's 3,600 seconds in an hour. So we do 12 times 3,600 to get our time. It's 43,200 seconds. Okay? So that means my omega is equal to the theta is 2 pi over 43,200. And when I go to solve for V, it's just the R for the hour hand, which is 0.05, times the omega, which was 2 pi over 4,000 or 43,200. So 0.05 times 2 times pi divided by 43,200. Enter. And we get 7.27. How many sig figs did I have this time, though? 1. That means that we're just going to write 7 times 10 to the negative 6 meters per second. That was an answer. That was an answer. And that was an answer. Okay? Y'all see how to do those? Okay. I think that's going to be all that we actually have time for. We got 2 minutes left. I don't think we're going to have time, but this is just the exact same thing, but backwards. So it's already given you the meters, and it's giving you the meters per second, so you're going to get omega. And then you convert your omega into RPM from rads per second. It's like, I can probably do it. Might as well. Given R is equal to 0.184. V is equal to 110 meters per second. Unknown is omega. The equation is V is equal to R times omega. I go to solve. I get 110 equals 0.184 times omega. Divide by 0.184. So I go to calculator. 110 divided by 0.184. Get 597.82. Rev over, rad over second. Okay, change my radians into revs. There's 2 pi radians in 1 revolution. And then change my seconds into minutes. There's 60 seconds in 1 minute. Magic fraction time. I got the answer that I had before, times 60 on the top. And on the bottom I got 2 pi. I get 5,708 to 2 sig figs. That is 5,700. Which is the same answer that they got, so I think I did it right. Scroll up, down. Which one? That one? Okay. All right, that's your review. I have tutoring after school today if you want to see me. See me after school if you want to talk about extra credit too, because we didn't have time.